Welcome to Ask and Learn.
We're asked to construct a deterministic finite-state automaton that recognizes the set of all bit strings that contain at least 3 zeros. This is going to be hard to describe in terms of smaller sets, so I'm just going to let S be the set of all bit strings containing at least 3 zeros. And let S0 be the start state. Let's consider 3 other states as well. So S0 is going to represent that there were no zeros in the previous bits. If, of course, there were any previous bits. S1 is going to represent that there was 1 0 in the previous bits. S2 is going to represent that there were 2 zeros in the previous bits. And S3 is going to represent there were at least 3 zeros in the previous bits. And it follows that S3 is the final state. Now let's think about the transitions. So suppose that we have a 0 in the string. Then we're going to move from start S0 to S1. Otherwise, if the string does not have any zeros, we're going to remain at S0. And now let's suppose that the remaining string has a second 0. Then we're going to move from S1 to S2. Otherwise, if the remaining string has no zeros, so the string in total only has 1 0, we're going to remain at S1. And next, suppose that the remaining string now has a third 0. Then we're going to move from S2 to S3. Otherwise, if the remaining string doesn't have any more zeros, so the string only has 2 zeros total, we're going to move, or remain, at S2. And now let's suppose that we're at S3 already. Then we're just going to remain at S3 no matter what the input is, since we already have at least 3 zeros.